All right, honors chemistry guys, we're going to continue on with our empirical and molecular formula lecture. This one will be shorter than the last one. Sorry about that 20-minute lecture on empirical formulas, but there was a lot to cover. So now we know one thing that you realized, obviously, is that an empirical formula is not the true formula for a compound. It's only the lowest whole number ratio formula for that compound. And so, we learned how to find an empirical formula from lab data, moles, mass, and percent composition, but that empirical formula is not the real formula. It's a reduced formula. And so is there a way, given that experimental data, that you can find the true or the real molecular formula, the formula that shows you the actual number of each atom's present? And the answer to that is yes. But you need some more information. In addition to the moles, mass, or percent data that you need to find the empirical formula, you also need to know an additional piece of information. And that additional piece of information is going to be available experimentally through the problem setup. And that last piece of information is the molar mass of the molecular formula. Well, why is that? Well, it turns out that, why do you need the molar mass of the molecular formula? Because the molar mass of that molecular formula is a multiple of the empirical formula. And it turns out that if we know what the molar mass multiple is, then we can actually use that multiple to go from the empirical formula to the molecular formula. And I'm going to show you how that's true here in a second when I scroll down. But it is true that if we know the molar mass of the molecular formula, we're going to be able to do a very simple calculation to find what multiple of the empirical formula is that molecular formula's multiple. Okay, so let's explore this relationship between the molar mass of the molecular formula and the molar mass of the empirical formula. As you guys can see, I've kind of joined you in the upper right-hand corner there. Actually, that's a photo that's about 15 years old. You can see no gray. I have no gray hair, no gray beard. That's actually at Miller Creek in Yellowstone National Park. It's about a 15-mile walk back into the backcountry, and when we set up camp in this spot, there's this huge elkhorn land there, and so I had my hiking buddy take a photo of me. So there you go. Anyway, a little bit of Mr. S history. Okay, so let's say that I have a compound whose empirical formula is CH3. Let's look at what the molar mass of that empirical formula would be. Well, it's the same way as you'd find the molar mass of anything. You take carbon times 1 and then hydrogen times 3. So carbon times 1, 12.011, hydrogen times 3, 3.024, adds up to a total molar mass of 15.035. Now, you also know that this empirical formula has several possible molecular formulas. We explored that in the last video. In fact, it has many. In fact, it could be C100, H300, and so on, etc. There could be many, many different molecular formulas that reduce down to that same empirical. So let's look at their molar masses. Well, the simplest molecular formula for this would be the same molecular formula, and you can see that it has the same molar mass because there's no multiple here. The multiple is essentially 1. In C2H6, which is where you would take both of these subscripts, multiply them by 2, well, you can see, well, what would that molar mass be? Well, 2 times carbon and 6 times hydrogen, and when you add those together, you get 30.070, and if you divided 30.070 by this number here, the molar mass of the empirical formula, you get 2. And you notice that that molar mass of a formula whose formula is twice as big, there's a multiple of 2 here in the subscript, that formula is twice as big, also has a molar mass that's twice as big, because it makes sense, because instead of 1 carbon and 3 hydrogens, you have 2 carbons and 6 hydrogens. So this makes sense, but what I'm just doing here is proving to you that the molar mass of the molecular formula if you find what multiple this molar mass is of the empirical formula, well, then you're going to be able to find how much you would multiply as a multiple in the subscripts of that molecular formula. Let's look at C3H9. Well, that 3 times carbon, 9 times hydrogen, that would add up to 45.105 total molar mass. And if you look at this compared to that 15.035 grams per mole, the molar mass that's of the empirical formula, well, that is 3 times the molar mass. And that makes sense, but we can see then, well, that comes from the molecular formula that was 3 times, essentially CH3 times that multiple 3, right? And that this again proves that, as I mentioned before, that the molar mass of the molecular formula is related to the molar mass of the empirical formula. And what we see down below, I kind of summarize that. It turns out that if we can figure out the multiple of the molar mass, well, that molar mass multiple is also what the subscript multiple would be, as I wrote it here. In this case, it would be CH3. And then I would multiply both of those subscripts by 2 to get C2H6, the molecular formula. Well, that molar mass multiple is the subscript multiple, but where would I get this multiple? Well, you're going to take the molar mass of the molecular formula and divide it by the molar mass of the empirical formula. Okay? So let's go through a sample problem using this newfound knowledge. Okay, so again, I rewrote that the molar mass multiple is the molar mass of the molecular formula divided by the molar mass of the empirical formula that goes with that molecular formula. And then that, if we divide those two, that becomes the subscript multiple that I would multiply the subscripts in the original empirical formula by to get the molecular formula. So, sample problem. An unknown compound has an empirical formula of CH. Now that unknown compound's molar mass is found to be 78.114 grams per mole. And again, this is always the molar mass of the molecular formula, and it's always available to us in this kind of problem. And it's actually, it turns out there are a number of ways in the lab. We can't do it. We don't have the right type of equipment, but there are a number of ways to find the molar mass of an unknown compound. So this isn't far-fetched, okay? So we can, right, know in a compound's empirical formula from moles, mass, or percent, and we can't do it, but in the world of chemistry, it's pretty easy to find a compound's molar mass if you have the right equipment. So what do we know? My empirical formula, and again, I'm modeling for you how I like to do these. I write down what my empirical formula is. I also want to recognize that my molecular formula is going to be that empirical formula with each subscript multiplied by some multiple. And that multiple, that subscript multiple, is going to be what we call the molar mass multiple. And that molar mass multiple from the formula above is calculated by taking the molar mass of the molecular and divided by the molar mass of the empirical. Okay? And when we find that multiple, then we just plug it in. So let's do this for our sample problem. So the molar mass of the molecular formula is always given in the problem, and it was 78.114 grams per mole. Then really all you have to do is, when you're given the empirical formula as you were, is go ahead, add up the molar mass of the empirical formula, which would be carbon times 1 in this case, and hydrogen times 1. And so the molar mass of the empirical formula is 13.019 grams per mole. So my multiple, according to my formula, is the molar mass of the molecular formula divided by the molar mass of the empirical formula. And when I divide that out, I get 6. And so that means that I'm going to take my empirical formula, I'm going to take each subscript in my empirical formula and multiply it by 6. And so I get C6H6. And that is the final answer. Again, on the worksheet, there are a number of molecular formula problems. If you run into an issue, then you can always contact me on one of the daily Zoom help sessions, or email or post on the discussion board your question, or some off hours you can send me an email if it's completely off hours. Okay, so that wraps up the video on how to find the molecular formula from an empirical formula. Take care, guys.